first thing we want to deal with is the classification of differential equations. So I've chosen two examples here. The first example is the second derivative of y with respect to x plus 9y equals sine of y. The first thing I notice is the 2 here and the 2 here. So this is second derivative. There is no higher order. So therefore this is a second order. The other thing I notice straight off the bat is that this is a full derivative. It's the derivative of y with respect to x. There are no partials. So I know that it's an ODE. But now I come to, is it linear or nonlinear? Well, I look at the left-hand side of the equals and I see, hey, it's fitting the definition of linear. It's of that general form that I've given you in class. But then I go to the right-hand side and I notice this function. Sine of y, first of all, it's a function of y. So therefore, I know it's not going to be linear unless I can take it over to the other side and incorporate it in with the 9y. But the second problem is sine is a transcendental function. So therefore, it's a transcendental function of the dependent variable. So that makes this non-linear. So we have a second order, non-linear ODE. Now I come to my next example. X squared dy plus y minus xy minus xex dx equals 0. So I want to play around with this sum and get it in some sort of form that I can tell what it is. So the first thing I'm going to do is I'm going to divide everything by x squared dx. And so what do I get? I get dy dx. And then the dx is over here, will cancel. And so I'm going to end up with plus y over x squared minus y over x minus e to the x over x equal to 0. So that helps me out a little bit, but I notice the two middle terms have a y in them. This one does not. So what I want to do is I want to take this one over the other side, and so I get dy dx plus, and I'm going to factor out a y out of this, so I have 1 over x squared minus 1 over x all times y equal to e to the x over x. Now it's in a form I know what it is. First of all, I notice what's the highest order here. The highest order is first order. So this is a first order. The second thing I notice is, again, I'm only dealing with ordinary differential equations. There are no partials in this. So it's an ODE. And then finally, I look at this form. Are there any transcendental functions of the dependent variable? No. The dependent variable and its derivatives are all to the first power or 0 power. So basically, if it's the form that I have for a linear differential equation. So this is a first order linear ODE. So that's how I look at it to classify what type of differential equation it is.